This lesson is on patterns in linear relations. So yesterday there was a couple videos about ordered pairs and converting standard form equations into slope-intercept form equations. Today we're talking about what is a linear relationship and how do we know if something is linear or nonlinear. So let's start. A relationship is a pattern that connects two sets of data. So if you have x values and y values, those are your two sets of data, and a relationship connects them in some way. A linear relationship specifically creates a straight line. So for every x value, there's a y value, and when you put them all together, they make a straight line. So what that means is if you find the first differences between all your x values, the differences are constant. Same thing for the y values, the differences are constant. So if you pick every single point along that straight line, all the differences are constant. And you don't necessarily have to have the same difference for the x values and the y values. You may have an x value difference of say 3 for every term, and the y value differences might be 2 or -1 or whatever. They don't have to be the same as each other, but they do have to be constant. All the x differences have to be the same, and all the y's have to be the same. Okay, so let's look at some examples of that to kind of clarify. So for these, we're looking at whether the relations are linear or nonlinear. If they are linear, we're going to fill in the next two entries in the table. So when you have a table of values like this, we always put the x coordinate, let me get this ready. We always put the x coordinate in the first column and the y coordinate in the second column like this. Okay, so first differences. You should have known how to do this from grade 9 math last year. So let's take a look. So I'm going to look at the x values first. The difference between these two is 2 minus 1. You take the second one and you subtract the first one, so the difference is 1. The difference between these two, 3 minus 2, is 1. So it looks like those differences are constant. For the y values, the second one minus the first one, 7 minus 5 is 2. And the second difference, the second first difference, 9 minus 7 is also 2. So it looks like these numbers here are constant. Our x values have constant differences, and so do our y values, which means that this relationship is linear. So for our next two entries in the table, we'll just continue the pattern. So we need a difference of 1 here. So that means we're going to go to number 4. There we go. And then we need another difference of 1, so our value will be 5. Our y difference, our first differences for our y values, 2, 2. So we're going to need 2 again, and 2. So 5, 7, 9, 11 will be our next value, and 13 will be our next. Okay? I'm going to start again here with a fresh drawing. So our second example, we have x and y coordinates again. So let's excuse me. Let's take a look at our first differences. So for our x values, the second one minus the first one, -2 minus -4. I'm going to write that down so it's clear. -2 minus -4. We're subtracting a negative, so we end up adding +4. So -2 plus 4 is 2. The next one, 0 minus -2. I'm going to write that down here because of lack of space. 0 minus -2 would be 0 plus 2, which again is 2. So it looks like our x values have a constant first difference. Y values. 5 minus 7 is -2. 3 minus 5 is -2 as well. So these are constant, these are constant, which means that we do in fact have a linear relationship. And this is somewhere where our difference here is not the same as our difference here, which is fine. So to continue this, we're going to go up by 2. So we had -4, -2, 0. Our next number will be 2 to give us another first difference of 2. And then our next will be 4. We have to go up by 2 again. Sorry, this is very messy looking. Over here, we're going down by 2. So we went 7, 5, 3, so our next will be 1, and then -1. And each of these will give us a first difference of -2 and -2. Okay? Clear this. Let's look at the third example. So we have x values of 1, 2, and 3. So if we do the first differences, 2 take away 1 is 1. 3, take away 2 is 1. So our first differences here are just 1. That's constant. Let's look at the y values. 6 take away 5 is 1. 9 take away 6 is 3. So we have a 1 and a 3 here, which means our x values do not have a constant first difference. We have a first difference here of 1 and then 3. They're not constant. Therefore, this one is non-linear. Okay? So if you were asked to show this, you would have to show your first differences like this, subtract your numbers, tell me what the differences are, and then explain x values are constant, y values are constant, therefore it's linear. Same thing for this one. For this one, x values are constant, y values are not constant, therefore it's nonlinear. Okay, so let's talk about what a function is. A function is a relationship that has only one corresponding y value for each x value. So what that means is if you have an x value in a table of values or on a graph or something like that, and let's look at it this way. For every x value along the x-axis, whether it's positive or negative, every x value only has one y value. So you could have something like this, that's a function. For every x I put in, there's one y value, like this. If it was something like this, for every x value, there's only one y value, okay? If it was something like this, which you will maybe eventually see in math, here's an x value with one y value. So right here, we have an x value here, an x value here that gives us a y value here, here, and here. So that weird shape is not a function because for every x value, there could be more than one y value. The other thing is that the x values can't repeat. So that's another way of looking at the same thing. So in that weird picture I just drew of the graph there, if we did a table of values for a graph like that, we'd have an x value, whatever this was, we'd have x, so say it was x equals 2, we'd have 3 values with 2, 2, and 2, and this one could be, say, I don't know, 1 for y. This one could be 2, this one could be 3. So our x values are repeating, therefore it is not a function. Okay, so a linear function is a type of relationship where the x values and y values, the differences between the x values and the differences between the y values are constant, and the x values don't repeat. So it's a relationship and it's also a function, a linear function. Alright, let's look at some examples. So we're going to determine if each set represents a linear function. So these little kind of squiggly looking brackets, there we go, sorry. These little squiggly looking brackets here and here, those mean a set. So we have a set of ordered pairs here, or a set of coordinate points. So basically, to find out if this set here makes a linear function, we're going to turn these values into a table of values, put the x values in order, determine if the differences are constant, and determine if any x values repeat. If all of that stands true, we'll have a linear function. If something doesn't work out there, then we'll have a nonlinear relationship. Okay, so let's start here. I'm going to erase those lines I drew. So looking at example A, we have an ordered pair of 1 and 4. We have an ordered pair of 2, 3, and we have one that's 3, 2. So there's our first step. We put the x coordinates in order, 1, 2, 3. We put the corresponding y values, and now we're going to figure out if the first differences are constant. 2 minus 1 is 1. 3 minus 2, also 1. Those are constant. 3 minus 4 is negative 1. 2 minus 3, negative 1. Those are constant. So our x differences are constant, the differences in the y values are constant, and we have no repeating x coordinates over here. There's 1, 2, and 3. We don't have anything where there's, say, another 2 or another 3 over here with a different y value. So therefore, we can say because of the first difference here, the first difference here, and no repeating x values, therefore this is a linear function. There we go. Okay, now let's look at example B. Again, we have a set of data points, so I'm going to put the x values in order. So we have 1, 2, 2, and 3. 1, 2, 2, and 3. So for our x1, we have y is 3. x2, we have y is 0. x2, we have y is 2. And 3, 3. So we'll figure out our first differences for our x values. 2 minus 1 is 1. 2 minus 2 is 0. 3 minus 2 is 1. So you may have already noticed we're getting some discrepancies here. We're going to continue, get all the way through this, and then we'll talk about what's wrong here. So 0, our first differences for our y value, 0 minus 3 is negative 3. 2 minus 0 is 2. 3 minus 2 is 1. Okay, so 3 problems with this that means it's not a linear function. First problem, the first differences for the x values are not constant. Therefore, it's not a linear function. Second problem, our differences in our y values, again, not constant. We have 3 totally different numbers here, not a linear function. Third problem, we have 2 x values that are repeated here. Another third reason why it's not a linear function. Okay, so hopefully that's clear. If it's not, be sure to let me know. Ask any questions.